session. This is where you go when you first log into Brightspace and go to our class. I will have the class recordings as an announcement, and it'll be the same announcement for all the recordings. So I just keep adding to that announcement. So by the end of the semester, you'll have a link to every presentation for the entire semester with a little summary of what we did. The reason there's one there now is because I have combined my Tuesday class and my Thursday class into one Brightspace class. So you'll see two different presentations for every class. I'll put both of them up there. I'll do both classes. They will cover the same ground, but it's possible, I probably ought to watch the one for your class because it's possible something will come up in the class that will be different from one of the other classes. So the passcode for our class session is always uppercase AEDD. The passcode for these recordings is different. It's a randomly generated code, so you're going to have to use that to get in. But it does work pretty well. It's in the cloud. It takes a little while for it to process, but once it's processed, I'm going to put the link in, and then you'll be able to get in there. I put this little note because I didn't want people to think when you go to the Zoom meetings and you saw that it's Tuesday and Thursday that you had to go to both classes. People can go to both classes if they want, but you don't have to. They're two classes that are covering the same ground. This, I put in just a little welcome to the class video in case you logged in at the beginning of the week so you could see how I go about teaching, but you're going to see me teaching tonight, so I'm not going to go through and cover too many of these things. But the open Zoom sessions are down here. And then some people were confused and they thought the open Zoom session was how you get into the classes. But I have to have a separate Zoom link for each presentation, but I have one Zoom link for all of my open sessions. So if you want to get into the class during this time, you go to communications, the drop down from communications, you get on the Zoom call. If at some point you want some help with something, that's the link, and that's the link for all 5 of these sessions. No, 4. No, I'm sorry, I do have 5. So I've got 5 2-hour blocks, that's 10 hours. AEDD is the passcode. So I tried to sprinkle them into situations where I'm available and they're different times of day. So I have one that meets in the evening in case people are working in the daytime. So Mondays from 5:30 to 7:30, but I'll be at home. So it'll be only Zoom. And then Tuesday, 1:30 to 3 o'clock, I'll be in my office here on this floor, which is the Ross Technology Center in room 211. And I'll also be on Zoom. Wednesday, same thing, but it's 10 to 12. So evening, afternoon, morning, afternoon. And then Fridays, I'm in Brunswick, and I'm teaching 2 classes for the Bath Iron Works apprenticeship program. And those 2 classes meet in the morning. And so I'm going to schedule an afternoon session in Brunswick. So if those folks have questions, they can come into that lab time afterward. But it's also, from my point of view, it's not on the BIW. It's not at BIW, it's on our campus. So I'm going to be in the L.L. Bean Learning Commons room if anybody happens to be in Brunswick. But I'll also open up a Zoom call. And if I have time, then I'll be willing to help whoever has a question. Make sense? Randall, we're good? Yeah? What's that? Something wrong with the system? Hang on. Okay, so you're good. Okay. All right. There is a general Google Drive. Now, did everybody get a link from me? Randall, when did you sign up for this class? Last week? It was earlier. It was before Monday. And Kaylin, you have a folder with you have a Google Drive that I sent you, correct?
Probably. I haven't really checked my emails that much.
Let me just make sure I set one up for you. I'm going to go and look. Oh, I can't do it that way. I haven't set that up yet. Okay, so I'm going to go to this over here. All right, so I'm going to go and get onto the Google Drives. So if you go to your email client through our website, and I have to Log in again. No, it's going to do it. Okay. If you go to those little dots up in the upper right-hand corner next to the gear and open it up, it'll give you access to the other Google applications, and one of them is Google Drive. Somewhere in here, you will find your name under Shared with Me or Shared Drive, and that is one I set up for you and sent it out. But what I'm going to do is check and make sure I set one up for everybody here. So we're 170.01. So Kaylin, you do have one. No, that's not you. Yes, you do, right there. So Kaylin, you do have a folder. It's right here. Um, Aiden, you have a folder, and Randall, you have a folder. Okay, so they're all set up. When I set them up though, you should have gotten an email with a link to that folder. So there are two ways to get to it. One way to get to it is to go and log into the log into the SMCC website, go to your email, do exactly what I just did, and find your folder there. So if Kaylin was interested in submitting some work, she could come up here, open up her folder. In that folder, I put a folder called Please Grade. You'd open that up, and anything you want me graded has to be in a folder inside the Please Grade folder. So far, so good? Make sense? Then you just right click, upload folder or folder upload, pick the folder that you put your work in, and then put it in the Google Drive. You're going to have to submit all your work in this class in the Google Drive because SolidWorks is a parametric software program that has three types of files: part files, assembly files, and drawing files, and they're all linked together. So that if you give me a drawing file, but you don't give me the parts in the assembly, I can't see anything. The parts are never in the drawing. They're simply linked to the drawing. So that means for every project, and that means every assignment, you make a folder for that project and then put every file involved with that project into that folder. With me on that one? Okay, Aiden, that makes sense? Maybe stepped out. Okay, so one way to get to this is by going to that. The other way is to go to that link I gave you. And in that link, you have to be logged into SMCC in order for it to work. But if you pick the link, it'll take you directly to your folder. So you can get to it one of two ways. There's also something called Google Drive for the desktop that I download. It's not on this machine because I haven't had a chance to do it, but it allows you to then use your Google Drive exactly the same way you do all your other Windows file management by opening up the file manager, and it puts a Google Drive over here called My Drive, and then you can deal with it exactly the same way you deal with all your other folders in Windows. And I put a video up showing you how to do that I'll point out later on. So go back to here. So the general drive, there's a link to it right here. And if you pick that link, it will take you directly into this general Google folder where you have a folder for all the classes we teach, including this one. And the information there are additional reference materials and other kinds of things that you might find useful, additional practice parts, additional practice for the certification exam, some templates for SolidWorks, and some other things. However, when I give you an assignment, and I'll show you in a minute how I set this up, I'm going to give you all the things you need to do that assignment. So you don't necessarily have to use this general drive, but there may be additional material there that will be helpful to you that you can find useful. Go back here. So when you first go into our Brightspace page, you go right to the home page. And the home page is where you're going to see announcements. And the announcements are going to be on the home page for as long as they're necessary. Many of them will be there for the entire semester. I expect you to read them. When I do a new announcement, if you set up Brightspace correctly, and you saw in the video that you watched, you saw how to do that, you should get a notification that I have a new announcement, and then you can go and read the announcement. If you go scrolling down through, you'll notice I've already got a number of announcements here. And the reason I do is because I wanted you to have certain information that was available anytime you might have to be reminded of it, including this one right here. So far, so good. Any questions right now? So we're using SolidWorks. When I first designed this class, I designed it and called it Parametric Solid Modeling because I was using Inventor. And Inventor, it turns out, this doesn't get used as much as SolidWorks, nearly as much. SolidWorks is the market leader. So we switched to SolidWorks. But for a while, I was allowing people to submit work in Inventor and SolidWorks or in any other parametric program. But that people never did. They always used SolidWorks. And at this point, I am no longer very proficient with Inventor because I haven't used it in almost 20 years. So you have no choice here but SolidWorks. Um, Now, how do you get to SolidWorks? You have three ways of using SolidWorks to do your work. One is to use the information contained in this announcement and download the software onto your own computer if you have a Windows computer that has enough capacity to install and run the program. It's a relatively demanding program, but most Windows computers will run it. You might not run it really well if you do really large assemblies, but it's going to do everything you need for this class right up until you start doing your own projects at the end, and you might do a project at the end that's a little more involved. So I have a video on how to install it. That video is linked right here. It's on my YouTube channel. And if you get down through, that's all the information that I got from them. And you have to simply go to that link, use that serial number, and do not give it to anyone else. I have exactly 60 licenses for the entire year, and I am going to come very close to using those up this semester, this year. So if you do download it, there's your serial number. It's for the campus, and they keep very close track of how many we have and whether or not people who have used it have an SMCC email address. So um, so that just tells you how to go about downloading it. It also indicates that I am entitled to administer CSWA, a Certified SolidWorks Associate Certification Exam, and all these other exams as well. The Certified SolidWorks Associate Exam is required by me for this class. It is not required that you pass it. It's required that you take it. And that'll be the last thing we do. And what I do with the results of that exam is this. I take whatever percentage of the questions you got correct, and I use that percentage to increase your final average. And I increase your final average only. I don't decrease it. Nothing that you do on that certification exam can in any way reduce your average. Why? Because it wasn't designed for a single semester class. And when I started doing it, when I first got this lab pack, the recommendation is that people who take it have at least 6 months worth of work experience before they take the exam. I want you to take it to get a sense of how well you are doing, how much you understand the software. And if you pass it, you've got something to put on a resume because you get listed in a database and an employer can actually check to see, did they really pass this exam? If you can pass that exam, and that is an international exam, it's taken online. I don't have anything to do with creating it, although I have told them in a couple of cases that they made mistakes, and they fixed them. But the pass rate for my classes over the past 20 years is 52%. That I still find kind of amazing because, again, one semester and people are passing that exam. And some people have not passed it by a very, very small amount because they were careless. And some people haven't passed it because they are terrified of taking exams. It's just a funny thing. In fact, I had somebody take this class one time with so much prior experience with SolidWorks that I was asking him for advice on how to do things, failed the certification exam dramatically. And when I talked to him about it, he said 15 minutes in, he just froze up. And that was it. Well, and the problem was there's a little clock in the lower right-hand corner. I said, I wish you told me I've got some blue tape. I would have put it right over that clock and would have gotten rid of it. I don't want you to be nervous about that at all. There's a practice exam that you take first. I'm going to give you 10 points just to take the practice exam. And that's just to give you a little sense of how it works, or more than a little sense. But at any rate, I also have vouchers for a lot of other exams, but very few people have ever been proficient enough to be prepared for those. But I have what's called the professional level vouchers. That's something you can take if you've passed the associate level. And I have had 4 people attempt it and had one person pass it. just with one semester class. So that person was unusual. Um, but it's even if you want to take it, I'll be happy to give you a voucher for that. But you have to pass the associate level one first. That, yes. FEA, certified. That's the not drawing two. Certified SolidWorks. I don't remember what that is. I've never taken that one. I've taken the drawing one. I've taken the sheet metal one. I mean the welding one. I've taken the professional exam. And there's a teaching exam, the accredited educator and technical educator exam. And I've passed all those, but I don't remember what the CSDA is. I don't know. We'll Google it and find out. But again, I have vouchers for them. So now I also give you some advice if you're going to install it on your own computer, some things that I suggest that you do. And then it tells you you don't need the mandatory updates, so just don't do it. Now, the thing about the announcements in Brightspace is they're on the home page, kind of look pretty nice, nicely formatted. When you get to the end, though, that doesn't mean there are no more announcements. If you pick show all announcements, there may be even more because it runs out of space. So to see all the announcements that I have up here, you have to go into the announcements page. And now you'll see that there are two other ways that you can use SolidWorks without putting it on your own computer. Kaylin, how do you normally work with AutoCAD? Do you do the virtual desktop or do you do it on
Yeah,
your
I
own
do the
computer?
virtual desktop.
You do. Well,
I
you
have a
do
MacBook.
so you can do the virtual desktop for SolidWorks as well. So the
Okay.
virtual desktop is something that's a link on the school website under My Workspace. And I give you a little video here on how to do that as well. You want me to hang on until you get plugged in? You okay? You can hear me? Oh, you couldn't hear her. Okay. Kaylin just said yes, she's been using the virtual. So Randall wants to hear Kaylin. I don't blame him. She sounds much better than I do. So, but the little video on how to use that as well. We have had really no problem with that up until toward the end of last semester, and we believe we have solved that problem. It got overused at the end of the semester in such a way that it was really laggy, but they think they have fixed it. And there is a well, those are the two ways that you can use the software. Now I've got a video in here on how to submit assignments. I'm going to go through that with you in a minute. And I'm going to show you a student has already submitted an assignment from the other class. I'm going to show you how he submitted that assignment and why he has to do it that way. But the main thing to understand about submitting assignments in parametric software is that you can't just give me one file unless it's just one part. A part file by itself has all the information about that 3D model. And by the way, SolidWorks is entirely a 3D modeler. It isn't even good at 2D modeling. And in fact, in my mechanical design class, when I cover CAM design, I don't start with SolidWorks, I start with AutoCAD because it requires that you create something that is called the displacement diagram, which is a two-dimensional diagram. And without it, you can't design a CAM, and SolidWorks just cannot do it in anything like a reasonable way. So this is a 3D modeling program right from scratch. Excuse me. So that means you need to give me sometimes, you might have an assignment with 15 to 20 files that all have to be available in order for me to see an assembly, or in order for me to see a drawing. As a result, you can't upload those to Brightspace. Brightspace doesn't know what to do with them. And all I'd be able to do was to download them, unzip them, put them in a folder, stick them someplace, then open SolidWorks and then open it. So it just takes way too long. My goal when I evaluate work is to get it back to you within a week of the due date. Last semester, I really ramped that up because I had so many students and I was getting things back within 2 or 3 days of the due date. I have more students this semester than I did last semester. So that's still my goal. And I think I will meet it. But in order to do that, I just can't have something that takes and slows me down. So what you'll do is you're going to put folders in your Google Drive and you're going to tell me that they're there. And I'll show you that in just a minute. But that video right here, if you forget what I went over, that video I went through and showed you exactly how to do that. As far as evaluating work, Kaylin knows. I think Aiden, if I had you in class before, Aiden, there's a You know, I don't think Aiden has. Okay, we got a chat here. Oh, I was there on Tuesday. Okay. So Aiden, I just noticed that you chatted there and I realized you don't have a microphone. So Aiden came to both classes, which by the way is perfectly okay with me. You want to go to both classes, you can. So here's the deal. And Randall, you might or might not know this. Um, I don't give grades that are not, well, you submit something to me, it has to meet standards. If it meets my standards, you get 10 points if it's on time. If it's not on time, you lose a point per week. If you submit it and it doesn't meet standards, you get a temporary grade of 5. And that temporary grade means you have to redo it and resubmit it. I'll give you feedback about what that is. And I think those of you old enough to have had jobs, and most of you are, nobody ever said you didn't do a good job on that, so we're going to pay you 80% of your salary. They say you have to fix that, and then we'll pay you your whole salary, right? So I've been teaching for 40 years, and the thing I sent out to you, I said this is my 80th semester because it seemed like such a big number, and that's all always technical education. This is how I've done this for my entire career, and it works. People learn the software, or they learn the material, not always software. As long as you do the work and recognize, I don't expect you to do everything right the first time because I've never done everything right the first time. The way you get and learn something is to try something, make a mistake, figure it out, and then fix the mistake and then go on from there. So I think this system works great. And in order for you to start off with a good average, I'm giving everybody 10 points for just responding to the email that I sent you and asking you the questions that are in that, answering the questions in that email, and then watching or telling me you have watched a video on Brightspace. So if everybody does that first really easy assignment, you all start with 100%. So now you get a 5 on the first assignment, and for a week or so, it doesn't look like a very good average. It still doesn't look too bad. That makes sense? Okay. Access to the Google Drive. I don't know why I put that on here. This is just for your information. There is now a non-commercial version of SolidWorks, which normally costs $2,500 to $4,000 a year. There's a non-commercial version available for $99 a year called the Maker version, and you don't have to buy that. But if you thought, I want to use SolidWorks and try to make a little bit of money, you can make up to $2,000 if what you're doing, and Randall, we're talking about a project you have. You might decide, I want SolidWorks to work on that project. You can legally do it for $99 a year, which is a hell of a deal. So that's why I put this thing up here. And I bought it myself just to see, tried it. It's exactly the same software. I didn't renew it. Did I renew it? I didn't renew it. I used to have an actual copy of SolidWorks, but now I don't need one because I get it educationally. There's a few other announcements up here that I will open up as we go along, but they're not right now. We're not ready for them. So the point though is this: when you look at announcements, they're not necessarily all on the homepage. All right. So the other thing about the way I'm using Brightspace, and it's different a little bit from, I know both Meredith and Paul have their classes set up a little differently. When we first were trained in using Brightspace, the process they gave us, I think, was unnecessarily complex. And what they said was under content, you should have a module for every unit. And under the modules, you should include everything necessary and the assignments. But there's also a tab called assignments, and the assignments had to be linked there. And so people were always confused about where to go. So what I've done under this content is I've put one type of content, and that is general information that you'll need all semester. It's not necessarily specific to a particular assignment. I'm also going to give you links to these things in the assignments where you need them. But the first one is a zip file containing drawing templates in SolidWorks. We'll get to the drawings and you'll realize that if you don't have a template, you're not going to be able to set up a title block without creating your own. There's a document that I've written called Best Practices, and we're going to spend some time in that document. I'm not going to do it right now because I don't want to get ahead of the game. I want you to have some experience first. But that's a 5 or 6 page document. And I'll say, just to indicate, you might be thinking, well, so he thinks it's best practices. So what does he know? I do have a book that I wrote called AutoCAD Secrets Every User Should Know, which is best practices in AutoCAD. That was written and published in 2007. And it is the only computer book on AutoCAD from that era that's still in print. And it is because it was not how to use every AutoCAD command, or how a beginner can learn the software. I wrote that for people in the field, and it's best practices. And that means it is how you use CAD software appropriately, and it's based on AutoCAD, but it's not. It doesn't go out of date. It's not specific to a particular version of AutoCAD. So the SolidWorks best practices. I'm not going to write a book about SolidWorks. That book took a long time and a lot of effort. Um, but I had a vendor that had some training one time, and they wrote and said, "Look, we've got they just wrote a general email. We've got some training for educators, and there's an introduction training, and there's a more advanced training." And so I wrote and said, I might be interested in doing that. I just want to, but I'm just not sure what it covers. But this is what I use as a best practices document. And they wrote back and said, "Can we use it? You don't have to take the training." So the fact is, there are other people who consider that to be really useful. And the reason I think that I have so many students passing the exam is because they use those best practices when they do stuff. There's a few other things here. One of them is, what's the difference between a viewing plane and a sketch plane? And that's because I had a faculty member take this class one time, and he was having more trouble. And I realized he didn't understand the Cartesian coordinate system. And he didn't realize that you could be looking at one plane and drawing on another. Then literally in SolidWorks, I can look at that wall and I can reach behind me and draw on this back wall. Well, I can't see what I'm doing here, but I'm looking over there, but it's still a plane. And so I made a little video to make sure he understood the difference. And then it cleared that up for him and it made it a lot easier. Very fundamental. If you understand the Cartesian coordinate system, and Kaylin, I know you do because you took AutoCAD, and if you really understand how that works, it's not very confusing. I've got something here that people on YouTube found very helpful, how to find underdefined sketches. We'll talk more about that later. So I put that there as well. And then everything we do from a drawing point of view has to meet technical graphic standards. So I put a PowerPoint that I've created that is very thorough, that deals with standards for mechanical technical graphics, based on the American Society of Mechanical Engineers standards. And it is a review of technical graphics, and it is many, many, many slides. And if you look down through it, it covers all the things that I consider of importance in mechanical design and in creating drawings that meet standards. So it goes down through and talks about everything involved with the stuff we need to do, including line types and line weights and orthographic projection. And then when we get down below, how you dimension things, how you represent threaded fasteners, and you get down to where there's a special symbols that are used, and you get down here to the rules for dimensioning, and you get down here and you start to deal with even more involved stuff. And then that is not what we're going to go over in this class entirely, but what we do in this class has to meet the standards of that organization. So rather than have you buy the standard, which is about $250 now, I've summarized it by using the same illustrations that are in the standard and then describing what it is that they are involved. When we get to drawings, this is going to be an important tool. I put it up there now, saying, if I were you, I'd download it and save it because it's a really thorough and accurate. And I've used that to do training for companies. I've done a lot of training for individual companies. When the engineers decide that they're all disagreeing about something and maybe they should have some training to figure out what the real answer is, I've gone in many times and used this as a way of reviewing for people what the standards are for technical graphics. So you have access to that. And that's it for content. Everybody with me on that one? So I have one module, module 0, and it has reference materials in general. Every assignment is going to be under assignments, and every assignment is going to have a due date, and every assignment is going to have a value as far as adding up your average. At the top, I have quizzes and exams. For this class, I'm going to have a midterm exam. You're going to take a practice certification exam at the end of the semester. And that one, all you have to do is take it. If you take it, I give you 10 points. If you don't take it, you get 0 points. And I mean 0 as in I average a 0 into your average. So I absolutely insist that you take that prior to taking the certification exam itself, which is down here. So those are the exams you're going to be doing for me. Just really one midterm, and then toward the end, we're going to prep for the certification exam. Then we have projects. All the projects add together, and that's your average. So your very first project is that email response. So if I go there and look, you see, these are the people that have already done that and they've already gotten their grades. And so there's nothing, if they did it, they got 10 points. So I'll just show you what it looks like. So Luke submitted his bright space orientation certificate and he responded to my email by answering all those questions. So he gets a 10. I pick okay or update. Now, bang, Luke has a 10 for an average right now. In other words, 100% because I have a 10-point system. So Luke has 100% average right now. Jefferson Carlisle, how are you? You got here all the way from Rochester? Maybe he hasn't quite gotten logged in yet. I got a note from Jefferson saying he was in Rochester and would be late. So anyway, I'm recording this whole thing, Jefferson, so you'll be able to go back and take a look at it. It'll be on there soon. It says connecting to audio. There we go. You made it okay. Still connecting. Okay, so can you hear me all right, Jefferson? And you are muted right now, so if you needed to say something, you need to unmute. So anyway, I'm going over right now. I haven't actually started any instruction. What I'm doing is going over the structure of the class. So that'll all be recorded. You can have that and you can go back and take a look at it. And then when we take a break, which we will do at 6:30, take a break for 10 minutes. If you have any questions, then I'd be happy to answer them. So let's go back to assignments. So as far as submitting work goes, right now I have one thing that has been submitted that I haven't graded. So this is from the Tuesday class. And so one student submitted exercise 1. I'm going to go over that in detail. So what happens when he submits it? Well, first, if I go here, open it up, first he puts all his files in his Google Drive, and then he gives me a text file. That's just a little file, and all it does is say, please evaluate. Let me see what he had. Please grade this assignment. That's all he needs. Because what he's telling me is, I put something on my Google Drive that I want you to evaluate. Otherwise, I don't know that he needs it evaluated. So when I get done evaluating it, and I shouldn't have opened that because now it doesn't say he's submitted it. So I'll have to go back and remind me. But I'm going to put a grade here. When I do the grade, if it's not a 10, or sometimes I'll do a 9 if it's like, I don't think you really need to redo this, but there was something that you didn't do that wasn't quite right. Otherwise, I'm going to give you feedback, and the feedback is going to be over here. And when you look at the feedback, you'll see a note saying feedback. When you open up the assignment, if you pick it, it'll show you what I wrote there. But more often than not in this class, what you'll see in that feedback window is a video, because I can make a video during feedback and bring up your project, show you what it looks like in the video, and mark it up and tell you what's going on with it. And that kind of feedback, Kaylin, I know, has had that kind of feedback from us. And I
Yeah,
think
they were really helpful.
really helpful, because instead of trying to read a paragraph describing what you did wrong graphically, you're looking at the object itself. And I will often just say, this is how you can fix this, but then I don't fix it. You have to go and fix it yourself. Hang on just a minute, folks. Hi. SolidWorks? Yes. Yeah, you can be in person. Just absolutely. Just sit right down at a computer, log yourself in. We started at 5:30, but I am recording the class. Oh, you were the one who got the email from. Okay, that's no problem at all. You don't have to apologize for that. Here's the thing. This is my feeling is we want people to learn this material, right? You're all adults. So you have 3 things you can do. Come here, and now I have 2 people here. Come to the Zoom meeting, and we're going to get on the Zoom meeting from here. So I'm going to show you how to do that in a second. Or you can watch the recording. And we're no longer like police officers trying to make sure everybody attends every class. What you do have to do is have some activity every week. And if you don't, you'll get an automatic email from me saying, is everything okay? You haven't had anything going on in the class this week. And if that happens 2 weeks in a row, what I'm required to do by federal law is to drop you from the class. Because the whole thing about dropping you from the class is not because we're being mean. It's because the federal government gives people financial aid. And if they don't go to school, then they're not entitled to get the financial aid. And so if we don't say they're not coming to school and they give them a check, then we're liable for the check that they gave them because we didn't tell them they weren't coming to school. There was also, after 9/11, another little piece added, which is if somebody doesn't come to class, but they're here on a student visa, we have to report that because some people in 9/11 were here on student visas, and so blah, blah, blah. So, but here's the thing. If I drop you from the class and you say, hey, I'm so sorry, my grandmother died and I just had to go, I say, fine, I put you back in the class. It's not a big deal. But to me, that's a much saner way to do attendance and for me to find out who's here, who's late. We used to have to literally say who's tardy, and how tardy are they? So, and if you can log on to the computer here and then go to our Brightspace page, and under the communications tab on the drop down, you'll see Zoom meetings. You can join the meeting and you'll see what's going on that monitor. Okay. All right. So anyway, let's go back to Luke Perry. So Luke submitted this and I know he submitted it. So what do I do? Well, I go to SolidWorks and I open it up. And where is it? Hang on. I got two monitors here. So I open up SolidWorks and I say, all right, I'm going to go and take a look at that. So I go to open and I go and find his work. Now, where is his work going to be? It's going to be on his Google Drive. So his Google Drive is going to be, and I'm going to show you his Google Drive right now. This is everybody's Google Drive in this class. So you notice that's how many people are taking this class between Tuesday and Thursday. So Luke has a folder and it is right here. And in that folder is a please grade folder. And what he put into his please grade folder is a folder called exercise 1. That is a folder containing everything necessary for this assignment. Everybody with me on that? Now, in this particular case, it's not as important, but I want you to get used to that because I want a project folder. When I open it, there are 3 files here, and those 3 files are the files that I assigned for one of the first assignments. So then I open them, I evaluate them. If they're all correct and they all do what I expected to be done, and there are no underdefined sketches, and the mass is correct, and they started from the front on one and from the right on the other, from the top on the other, he gets a 10. We move on from there. If there's something going on, he's got an underdefined sketch, I open it up. I show him how I found out there was an underdefined sketch, how he can find that out. I go in and look, and I don't necessarily point it out, but I point out that if there's something blue, it's underdefined. And so that's how we're going to go back and forth. Hang on, folks. No, that's okay. You don't have to apologize. So, that's the previous recording. Upcoming meetings right there. Go over to join. There you go. So you were looking at old recordings from earlier. So there you go. Now save this. Now double click on it right there. Yeah. All right. You're gonna install it. Makes sense. I think that's just gonna go through, but stop me if it doesn't work. Okay. You're welcome. So anyway, that's the process. Everybody understand that? You're gonna put stuff in a Google Drive. You're gonna tell me that it's there. If you don't tell me it's there, I'm not gonna look for it. If you don't put it there and tell me it's there, I'm not gonna find it. Everybody with me on that one? Now, somebody's going to mess this up at some point. It happens at the beginning of the semester all the time. And then once you mess it up and I show you why it's messed up, which I'll do in a video, you'll go, oh, that's why he wants everything submitted in one folder. So that's that process right there. Yeah, that is, I think that's enough of the general how I set up Brightspace thing. When you do end up looking for your grades, I'm going to change my view to a learner. AEDD uppercase. AEDD, all in uppercase. And that's Architectural and Engineering Design Department. And you are in. Okay, so go to your grades. And when you go to your grades, what you're going to see is, and this is me, so I don't have any grades, but there'll be a grade for each assignment and there'll be an average. You'll have a running average all semester. Because of my system of not giving you a full grade until it's right, sometimes people will have a couple of assignments out that have 5s. So your running average isn't necessarily a reflection on how well you're doing. It may be skewed by the fact that you have some things you have not yet resubmitted, but all your grades are right there. And when you have something that's graded, over here under comments and assessment, there's going to be a button that says feedback. If you don't click it, you won't see my feedback. You have to actually open that up. I say that because I had a student last semester who went most of the semester not understanding, excuse me, why his average wasn't going up, because he never read the feedback and didn't realize he had to resubmit stuff. So I thought, I mean, that's the reason I asked people to watch that video on Brightspace so you'd understand how to go through that. The other things that are up here, communications is where our Zoom meetings are. If you go to the Zoom meetings and you look up here, you have upcoming meetings. You also have previous meetings. You also have a personal meeting room you can go to. And then there's cloud recordings. And the cloud recordings are all the recordings of, in fact, I could have just told you go there looking for the cloud recordings instead of putting them in announcements, but I wanted to put a summary of what the recording was about. So they're all there and they're going to be there until about a year from now, and then they're going to be deleted. And then under resources, you've got some Brightspace stuff that I'm not going to go over right now because it's not specific to SolidWorks. Now, any questions? Jefferson, Kaylin, I know you're involved. Jefferson, you're all say. Randall, you're good. Aiden, Carter, yeah? Okay. So now I want to go back to assignments. And I just want to point out that you have three assignments that are open right now. One of them is that email response assignment. And again, you should all have gotten an email from me and it just asked you 10 questions. And there's a reason. I want to know what you want to be called. And I won't remember everybody's name all the time because I'm 73 and I forget stuff. So, it's just the way it is. But I do want to know. Well, one of the things that I want to know really what people's and what their majors are. I'm not going to skew this course in any way because it's mechanical design, whether you're a designer or a machinist. But I was a machinist and I kind of focus this on what I consider helpful to the precision machining students in terms of creating an understanding of CNC before they get into it. And I want to know how many hours you're working and how many classes you're taking, because I just want to flag any situation where I'm thinking that's an awful big load. And what I've done, and I have one student and she's done this now twice. So she's successfully done it, but she's working full-time and taking 4 classes. I almost never see people succeed at that. And I always wince a little bit. So I turn into Uncle Dan when I see that. And then part of it is just saying, listen, you got a very challenging load. Let's keep an eye on that. Please let me know if you start to fall behind, if you have some difficulty, and let's talk about it. Sometimes people, especially younger people, think they've got to get things done right now. When I say especially younger people, I don't know. It's just my experience. Somebody out of high school, no, I got to get this done in 2 years. And I go, why? Well, it's a 2-year program. The most successful person I know went through it in 7 years because in the middle of his first semester, he got hired. And then his company paid for the rest of his education. Took him 7 years. He had a 0 debt when he was done. But he did have a house, a pickup truck, a wife, and 2 kids, and he'd been promoted 5 times. So don't tell me you got to do this in 2 years. You don't. What you have to do is learn as much as you can and get your money's worth. So I'm going to give you 2 assignments that are due fairly soon, but I've given you a fairly long period of time on these, considering what they are. Once you're really familiar with these things, you might go, boy, that exercise 1, that's kind of a lame assignment. It only took me about 20 minutes when I just did it. Maybe 30, but we're just now learning how to use this software. So I'm going to give you an exercise that I've created, but I'm also going to show you a tutorial that comes shipped with SolidWorks. I'm going to have you do that despite the fact that I don't like some of what it does, but I want you to get used to the idea of going and watching a tutorial. They have a bunch of them that ship with the software. So I want you to just sort of see how they work and how it's set up and go through it. So you have sort of 2 different approaches to how to create parts. And it also gives you a sense of what a drawing looks like as well when you're done with that. So we're going to start doing that very soon. And I'm going to spend the rest of the class presenting that and showing you how to go about doing it. But I just 2 other things that I want to do before I start doing that. And one of them is to show you that in many of the cases, I've got links to YouTube videos, but those YouTube videos are all links to mine. I don't link to anybody else's YouTube video. And it's not because there aren't some very good YouTube videos on SolidWorks. There really are, but they frequently violate some of what I consider best practices, and frequently, really frequently. So I'm going to show you, if you go to YouTube and just type my name, and you can type my name in SolidWorks or SMCC, but normally if you just type my name, yeah, it's the first time I've ever done this on this computer because they just redid it. So you notice that's the first one that comes up. So I put my photograph up here so you'd recognize who I am. I put this up strictly for students, but I made them public so students could get access to them anytime and it'd be easy to do. And then I thought when someone graduates, they might want to go back and look at a video again. And if I had them only available to people while they were in school, then they wouldn't be able to. It didn't occur to me that people would subscribe, but I have now 5,620 subscribers from all over the world, and almost none of them are students. And, I might have had that many students in my 40-year career, but they didn't all sign up for this. That really shocked me. I didn't even know that until someone said, "Did you know you have 1,000 subscribers?" And I go, "Subscribers to what?" "Your YouTube channel." I said, "I have a YouTube channel." "Yeah, you do." "Well, I put YouTube videos up, but it's not a channel, is it?" "Yeah, well, it's a channel." So anyway, and the thing that's been interesting about that is I get a lot of feedback from people around the world. And some of it has been really helpful in terms of recognizing things that could have been designed a little differently. Um, there are playlists I have under here for all of my classes. And one of those playlists is for AEDD 170. There's also a general playlist for SolidWorks, which is someplace. Where can I see it? Oh, right there. Um, so the point I'm making here is this: even like exercise one, I show you exercise one in this video. So if I don't quite cover everything I wanted to do today, I'm linking this video to the assignments. You can go back and watch that video. But the preparing for the professional certification exam and preparing for the associate level exam, this is the one that stuns me. 295,000 views on that. And hundreds of people have watched it. And there's like 400 or 300 comments on it. And the thing about that that tells me is that people have been very, very appreciative of that video. It really is a helpful video. And that's the one I made for my class. But I also get people who say, "I did exactly what you did and I don't get the same answers." And invariably, when I say, "Well, there's some best practices you probably didn't follow. Go and make sure that all of your sketches are fully defined. But by the time we're done today, you'll know exactly what I mean by that." And most of the time, that's all that it takes in order to satisfy that. So there are a number of things under the SolidWorks one, and even a number of things under the class one that are not really so much part of the class. For instance, a wind blade, how to design a wind blade. I did that with a composites class I was teaching. Um, there are a number of other things here. There's a weldments set that something about weldments for a company wanted me to come up and do some training in weldments, but they were, I think, in Millinocket. I just didn't want to go there. So, I mean, I like Millinocket. I just didn't want to go up there. So anyway, but those are some supplemental things as well. What's that? A weldment is in SolidWorks. A weldment is where you take and do a three-dimensional model, but it's just lines. And then you say, this is the cross section of the material that I want to use. So suppose you're doing, in fact, the company, yeah, right there. This company makes, let me just see if I can get to I've got to skip something. I will say one other thing, as long as we're talking about this. I don't have any control over the ads. The ads are at the beginning and the end only. And in order to do that, I had to monetize the site. And by monetizing it, it gave me control. So no ads appear in the middle of my video. The ads at the beginning and the end, I say nothing having to do with the following list of every single thing available. No alcohol, no, whatever, no. And any ad at the beginning and the end has to be skippable. You have to be able to skip it after a certain amount of time. What that does is reduces the amount that they're willing to pay for people who have them up. But I don't do this as a monetized site to make money. So I just want you to know that if there's an ad and you find it offensive, it's not my ad. It was just put there by YouTube, but I will say this, that they are pretty good. Normally they are about computer aided design, or something along those lines. So anyway, that's a weldment right there. And a weldment means you draw a line from here to here to here. You indicate what kind of material, you do the cross section, and then it creates each of the individual pieces and cuts the angle for you and shows you what it's going to be. And that is to go on the back of a pickup truck to cover the rear window so you don't break it when you throw stuff in the back. And this company has welded aluminum frames that they do for pickups. And so when I did the video, I said, send me something that you make, and I'll show you a video on how to use SolidWorks to make it. And it's got all kinds of tools for cleaning up those corners and a few other things. It has to do with welding in the sense that you will then weld these parts. But the beauty is you get a cut list from it. It shows you the overall length, the angles on each end, even the compound angles. And when you do that, you can then cut these pieces, put them together. It'll even, well, I won't go into any more detail on that, but it's really, really an interesting tool. What I'm going to show you right now, though, is I just want to show you one project overall. And this project overall is something I did with sheet metal. Now, we're not going to deal with sheet metal, but it shows the project itself. And I'm looking for drawing file. Hang on just a minute while I find it. It'll take me just a second to find this. Should have had this set up before. Yeah. I just want to show you the scope of this of a particular project. What happened when COVID hit? I got suddenly a lot of design projects to do. One of them was with Maine Medical Center for a part that they needed if they were going to try to put more than one person on a ventilator. Made 400 of these little fittings I designed for the Maine CDC. And luckily, they never got used because the need for ventilators dropped and the number of ventilators available dropped. I made a mask for a company that makes filtration material because they can make N95 material, or actually 95 material. So they thought if they had a flexible mask for a physician and for nurses, they could just replace these little things when there was a shortage of masks. I did a bunch of stuff on face shields, all of which was great because it kept me busy. But none of those got used. But the one that did was this. The governor called the president of our system and said, would you ask Dan if he can design a drop box for voting? Because people don't want to go to voting. They don't want to go to the voting places, the polling places. And so we want to be able to provide to any community in Maine that wants one, a secure ballot box that they can put outside and people can drop their ballots into. So I designed this using SolidWorks sheet metal tool. And what I'm just going to show you is how these things are all connected. This is a drawing with a set of sheets. This is the assembly of this drop box showing it. And by the way, I did this with the Secretary of State's office and they have zero mechanical abilities. They just don't. So I was really wanted to be careful to give them tools that would help them visualize. This right here, to me, is very clear. To them, it made no sense at all. That made sense to them. And so that's what I put in there. But if you look here, this is a set of drawings created from the assembly and then each of the individual parts. So there's a door. The door is a sheet metal door. That's what it looks like folded. That's what it looks like in a flat pattern. SolidWorks has a tool for doing sheet metal that allowed me to create that flat pattern from what I started with was the final folded version. I didn't have to start with a flat pattern, which is kind of a miracle to me. My first job, I was 15. I worked for my uncle, who's had a sheet metal company in Detroit, Michigan. And I went out there and spent all summer working for him. And he would create patterns that we then had to cut and fold and they would turn into stuff. But he didn't start with the stuff. He knew where he was going. But all of these things I created, and I won't show you exactly how this works, but you can see these are fairly complex. That's the hood that goes on the top. That's the big box right here. And there's an auxiliary view, and that view is showing you the slot, is showing you the front, showing you the right. Those are standard, orthographic views. But then showing details of the sheet metal tab kinds of things. all of this was done with tools in SolidWorks that make creating drawings so much easier. So there is the large ballot box as a flat pattern. Now, so that's the end result, right? Now, if I go back, if I go to here and I right click on this and I say I want to open that up, it'll open that part up for me because this part is not in this drawing. The part is separate. So when it opens the part, it looks like this. Eventually opens the part. There's something that is asking me someplace that I don't see. I think it's still thinking. Nope, there it is. So it opens the part and the part looks like this. But that's the part looking like that once it's folded. Now, once it's flattened, I mean. Folded up, what's it look like? Folded up, it looks like that. So this is one part. It's in a drawing file, but it was also used in an assembly. So if I go back up to, they just there we go. I got to pin that. They just image this computer, so it doesn't have things set up quite the way I usually like them to be set up. So I'm just going to go back to the sheet, and I'll show you just one other thing. And that one other thing is under sheet one, there's the assembly. If I right click on the assembly, hang on. If I right click on the assembly and open it, now you're going to see all the parts put together into an assembly. And the assembly of that thing looks like this. Now, this is made out of stainless steel. It's all welded, very secure. They've been using them ever since they had 76 of them made. They distribute them all over the state. They've been used since then. Not one of them has ever had water in it. Not one of them has ever been vandalized, and not one of them has ever had anybody pour coffee into the top slot, which is what sometimes happens in mailboxes. Why? Because it's really hard to push your hand back there. You bump it against that and tip your coffee, and mostly it would run down here. You know, that locks, this locks, but it's simple enough that a company can make them. We had 1 month from the time they asked me till they got produced. We had a company that literally made all 76 of those things. Once I went through and they did a prototype, I went back and modified something. I gave them all the plans I had for the flat stuff. They laser cut all those things, folded them up. They brought in all their welders and they delivered all of them in time for the election that year. And they did one hell of a job, but simple enough to make, stainless steel, they'll last forever, lockable without having some kind of crazy, complex whatever. So the reason I'm showing you that, I'm quite proud of it. So part of it is just shameless bragging. But the reason is to give you a sense of where we're headed here, because we're now going to come all the way down to the part level, and that's where we're going to start. But I just wanted to show you this tool is a design tool. And if I didn't have it, when the governor asked if I'd design it, I'd have said no. If I had AutoCAD, I'd say I can't do it. There's no way I can design that. And there's certainly no way I can design it and do the patterns and provide them with files that could be used to automatically cut stuff so that we could have a timetable that was going to work. SolidWorks was the only reason I was willing to take on that design project because it's a fantastic design tool. And I keep using the word design because so much of what we do when people are learning software is say, here, duplicate this, duplicate this, duplicate this. SolidWorks is not for duplicating things. SolidWorks is for designing things. However, we're going to start by duplicating things so you know how the tool works. Make sense, folks? Everybody with me on that? Okay, let's take a 10-minute break. It's just a little bit past half hour. So come back in 10 minutes and then we're going to jump right into the assignment. And I'm going to go through multiple times how I want you to approach creating parts. And I am going to stop sharing and I'm going to mute myself and I'm going to turn off the video because I need to go make a phone call and well, I can leave it open, I guess. So you can look if you want, you can look at this. I'll be back. You're all set? Is that all okay? Yeah, you can see okay here? Yeah, I was pulling up. Yeah. It's been, I dealt with SolidWorks my freshman year of high school, but I forgot to get all. The reason I say good, you may have had a fantastic instructor. The trouble is, I get a lot of people who had something. I just have to have it. So a lot of times, All right, back. A little late. Well, not really, I guess. Okay, so let me share the screen again. Anybody have any questions based on what we did so far? We're good. All right, so what I'm going to do now is I'm going to just eliminate this and close that as well. Don't save. And we'll close that. All right, so let's start with the general overview of SolidWorks itself. There are three types of files in SolidWorks. If you go and say you want to start something new, it's going to give you a choice of three things. And those three things are parts, assemblies, and drawings. It's possible to start with an assembly and build all your parts inside one assembly called top-down design. I'll have a video on that, and we'll have you do some of that later. It's normally, for people who are new to this, confusing though. So we're going to start with parts. So we're going to make a part, we're going to make another part, we're going to make another part, we're going to put them together. So we're going to do this individually. So you start with a part, and when you do, you've got to make a critical decision to make. Are you drawing in millimeters? Or are you drawing in inches? Now, SolidWorks, unlike AutoCAD, knows the difference, which means if you think you're drawing in inches, but you're actually drawing in millimeters, you end up with something that is very tiny. If you think you're drawing in millimeters, but you're actually drawing in inches, you end up with something that is very large. How large? 25.4 times bigger, right? So there are ways to solve that, but you're not going to get any of those ways from me yet, because the ways to solve that are not foolproof. So down in the lower right-hand corner, let me see if I can get the magnifier to work on this thing. I don't know why that's taking so long. There's a magnifier app that comes built into Windows that is set up in a weird way. Let me, well, they just redid this machine. Huh. All right. Well, what I'm showing you is over here in the corner. I'm going to have to get out. Right now it says custom, and that showed you the units. What we want is inches, pounds, and seconds, or millimeters, grams, and seconds. For this first assignment, we're going to do it in inches. Most of the work we do in this software is going to be in millimeters, partly because the certification exam is all metric, but I'm going to select inches for this. And now try to figure out how to turn off. There we go. Okay, so now down in the low right-hand corner, it should say IPS. And again, if it doesn't, you kind of have to start over again. For everything you're doing for me, if you mess that up, you just have to do it again. Now, if you take a look, you have a large drawing area like you do with every CAD program. Every CAD program is based on a Cartesian coordinate system, which is why if you look over here, where you have a number of things going on the left, one of those things is a listing of every element of this part. And so it's known as a tree. And that tree is going to show you all the features and how those features were created. Every SolidWorks part file and every SolidWorks assembly file starts with 4 items in that tree. There's a few other categories of things, but as far as the items go, you have a front plane, a top plane, a right plane, and an origin where all 3 planes intersect. That's the Cartesian grid. Now, understanding that, we're going to start everything we do as a part with a sketch. And that sketch can be either a 2D or a 3D sketch, but doing a 3D sketch makes no sense right now. 3D sketches are useful for weldments, where you have things going all over the place, or piping systems that are going all over the place. And that means you're just creating paths when you do that. But to actually create geometry, what we're going to need is to create a sketch first. At the top, you have all these tabs. And those tabs are basically categories of tools. I think of them as toolboxes. So we're going to deal with three of those tabs in this class: features, sketch, and evaluate. There are a number of other things on here. We're not going to deal with those in this class. At least I'm not. You're welcome to do anything you want with them. And I'll talk about those maybe at some point. But for right now, we're dealing with the fundamentals. A sketch is what you use when you want to start to create some geometry. If you pick the sketch tab, nothing happens. It opens up a toolbox where you have the tools necessary for sketching. And that means including the tool saying, I want to sketch something. So people sometimes get confused. They say, all right, I'm in Sketch. Why isn't anything happening? Well, you're in Sketch, but you haven't said you want to sketch, because there are two types of sketches: sketch and 3D sketch. We're going to do a 2D sketch. The minute you do that, it tells you you can only sketch on a flat surface. Pick a flat surface. Oh, you don't have any flat surfaces? Pick one of these planes. So you have three places that you can sketch. So if I come over here and say I want to sketch on the top plane, I hover over the top plane, it turns orange. I hover over the front plane, hover over the right plane, whichever one I pick, left click, it will orient to that plane, although you can turn that off, and it'll leave you only with an origin. No matter what you have seen or may have seen, if you go on YouTube and look at videos, no matter who tells you that the origin doesn't matter, they are absolutely flat out wrong. Everything you do has to take the origin into account. So if that origin is not taken into account, you cannot fully define a sketch. So what is fully defining a sketch? I'm going to draw just a rectangle, and I'm going to randomly draw it without taking the origin into account. That rectangle right now is a rectangle because it has relations. Two of the lines are horizontal, two of the lines are vertical. They have to be that way. If I try to do this, unlike AutoCAD, where that becomes distorted, it's always a rectangle because of those relations. Those little green things show you what the relation is, and the relations are geometric. Excuse me. The other thing you can do to control a sketch is dimensions. If you look up under here on the sketch toolbar, all of these tools for doing everything you need are here, including something called Smart Dimension. Now, there are tons of dimension tools here. I have only used two of them ever in all the work I've done: Smart Dimension and Ordinate Dimension. Well, also when you do drawings, there's something called a chamfer, but that's another matter. So all I'm going to do is pick Smart Dimension. I say, make that line right there 4 inches long. I type a 4, it's now 4 inches long. I come over here and say, make that line right there 2.5 inches long. I type 2.5, it's now 2.5 inches long. This is backwards from the way AutoCAD works. AutoCAD, you create geometry and you know the size as you're creating it, or you modify it later. Parametric means that the shape of that sketch is driven by the parameters, and those parameters are relations and dimensions, which means if I change my mind and go, you know what, I really meant that to be 3, I change that to 3, and it literally changes to 3. The sketch changes to 3. Everybody with me on that? This drove me nuts when I first started to learn Inventor. It was because I was so used to AutoCAD. I wanted to tell it exactly how long to make things. But I'm sketching right now, and I'm putting stuff in that I'm guessing at, and I'm probably going to change. So the fact that I can sketch, change the number, and have it change the sketch is huge. Right now, it doesn't appear to me that there's anything missing. I know it's a rectangle, horizontal, vertical. That means those have to be 90 degrees. 3, 4, there's nothing else. And yet it's blue. Blue means, I'll go back to the magnifier because I don't think otherwise you'd see it very well. Blue means right there that it's an underdefined sketch. If it says underdefined there, do not submit that to me, because anything you submit that has an underdefined sketch will automatically be returned and have to be redone again. Everybody hear that? Underdefined, I won't accept it. I'm going to force you to get in the habit of fully defining all your sketches. So what's not fully defined about it? Well, if something's blue, it's not fully defined. So if you pick that rectangle, you'll notice I can move it that way. I can also move it this way. Why? Because I don't know, and it doesn't know where that sketch is located on the Cartesian grid. If I take that corner, hold my control key down and take the origin, now I can make those two things coincident. And you'll notice when I do that, everything's black. Why? It's fully defined. What does it say down here? Fully defined. Everybody with me on that? Now I can turn that into something. To turn it into something, I need to get out of the sketch toolbox and go into the toolbox that allows me to create features. So evaluate, we're not going to get to right away. We're only now talking about these two tabs. When I'm done sketching and I have a fully defined sketch, I'm not saying I always have fully defined sketches, but when you submit something to me, it has to be fully defined. If I'm designing, I might not know those dimensions. When I did that ballot box, I put what I thought made sense, started with it, found the volume, checked to see what volume should a ballot box be, went back, tweaked a few things. When I finally got what I wanted, then I fully defined the sketches and then I was able to go. And over here under features, you can do something with that sketch. The two things that we're going to be doing here are extrusions, extruded bases, and extruded cuts. But there are other ways to create solid geometry. An extrusion allows you to take a shape, push it through space, and turn it into a 3D model. Now, if I want that to be 1.5, I do this, and I don't usually grab it to do it. I type it in. Now I've got a parametric object that is really bizarre because it's got shadows, because by default, this drives me crazy. I do not want shadows. I hate shadows. I don't want them at all. I also don't want real view graphics. I want a nice, clean looking, nerdy kind of model just like that. So I'm going to get rid of those things. So now that is a parametric solid model. It has a mass. It is solid. If I were to cut it in half and take a look at it, bring it up through like that, looks like that on the inside. I get rid of that cut, looks like that. Now, that's called an extrusion, and it's no different than what happened when you brushed your teeth this morning and you squeezed your toothpaste tube and moved it and made a cylinder. You extruded your toothpaste out through the hole that was round. If the hole was star-shaped, you'd have a star-shaped toothpaste. And by the way, I always wondered why they don't do that. Wouldn't that be great kids' toothpaste? Like weird little shapes they do. If you're doing Play-Doh and you crank the Play-Doh, that's an extrusion. That's exactly right. So if you have kids or you play with kids, make sure they know to call that an extrusion. Get them right now, understanding that's. But here's the thing is every 3D computer aided design program calls that an extrusion, every single one of them. So now that's an extrusion. Well, how do you put a hole in something? Well, we have to go back to sketch for this and tell it we're sketching. Now, the minute you have something that has planes on it, stop picking the planes that are Cartesian and start picking the surface you want to deal with on the part itself. So I come over here. I say I want to put a hole through that. I'm going to put a circle on there like this. I'll put a dimension on it. The dimension in this case, I'll just make it 1. It's not fully defined. Why not? Well, because I don't know how far from here it is. So I'd have to put a dimension there. For instance, I'd put a 2. I don't know how far it is from here to here. I'd have to put a dimension on here. Oh, wait a minute. I did know how far it was from there to there. What I don't know is how far it is from here to here. So let's call that 1.5. Once I've done that, now I have a fully defined sketch. Now when I go to features, I don't do an extruded boss, because if I do, it'll just put another solid inside a solid. Instead, I'm going to do an extruded cut. And when I do an extruded cut, I'm going to tell it where to start, and I'm going to go over here and tell it how to cut by saying go up to surface. I'm going to pick the surface I want to stop at, and I'm going to do this, and now I have a hole through that. So those are the fundamentals of extrusions. That makes sense, everybody? I didn't find the center. I just put a dimension. So here the question is this: I missed the part where you found the center. It looked like I hate that thing. This is good because this is how SolidWorks will look when you first install it. So I'm going to go up here and say, do not show me that little cube. It gets in my way. If I press the space bar, I can say, what's it look like from the front? What's it look like from the top? And if I do this, what's it look like isometrically? It'll look like that. I didn't go to the center. I just put a dimension. So I showed the length of the distance from the center to that edge and the distance from the center to that edge, which then fully defined it. So all I was doing was trying to fully define it. I wasn't trying to go to the center. I could have gone to the center, but I didn't. Listen, that's fundamental stuff. Now I want to draw a real thing. So what I'm going to do is this. I'm going to throw that away. In fact, I'll just throw it away this way. And I am going to go back and open up assignment 1. And assignment 1 is, am I looking at? Okay, assignment 1 is here. And oh, by the way the assignments are going to look, something else that happened last time that I want to avoid happening this time. If you go to assignments, I had a student who would look at an assignment like this one, and he'd open the attachment and then try to figure out what to do with it. If you pick on exercise 1, it tells you what to do with it. That's the assignment right there. And in this particular case, I'm going to have you make a part 3 times. I'm going to have you start it from the front once, from the top once, and from the right side once, and make 3 different part files. And I'm doing that because I want you to go through this multiple times, and that gives me a way of showing you different approaches depending on how you start. The attachment is where the assignment is. So if we open that up, the PDF file, will it open in this or not? They just got this machine put back together today, and this is the first time I've used it. So you might find me going, no, that's not what I wanted. Yeah, it's good enough. Yeah, all right, that'll work. All right, I'm just going to minimize this. I'm going to take SolidWorks. I'm going to park it off to one side. Then I'm going to bring the assignment sheet over here so we can see it. So what we're doing is creating that part right there. It's a hold down. It's a very simple part, but it's got just enough complexity for me to represent things, but also it's simple enough so I don't have to worry about you not understanding what it is. So that's what it looks like. And we're going to put material on it. We're going to check and see whether or not the geometry is right. And I'm going to show you exactly how to check your own work so you know it's perfect before you turn it in. So when you turn it in, you'll get a 10. Now, does everybody get a 10 on this assignment? No, not even close. So pay attention. But a lot of people do. So what we've got up here is an orthographic view of this hold down. And I can basically start this from any point of view. You're starting it once with a top view, once with a front view, and once with a right side view. I'm going to start with the top view. But I'm not going to jump in and just start drawing. I'm going to analyze this part instead. Somebody just come in? Yeah, I do see somebody. Okay. Oh, Matt, you got in all right, huh? Yeah, I got your email. Listen, I'm recording this. You'll be able to see the rest of the recording. And I just started doing a presentation on the assignment. So you're here at a good time. Okay. All right. So what I'm going to do first is look for symmetry. And symmetry means, is it the same up here as it is down here? And there is absolute symmetry on the top view and the part above and part below. I'm going to use that. There's symmetry in this view over here. There's no symmetry in the front view. The origin has to be someplace logical. If you have an origin placed like just randomly, I'm going to say, why is the origin there? And if you can't give me a good reason, it's wrong. So what's logical here? To me, there's only 2 places that the origin could be here. It could be at the center of that slot, potentially, or it could be right on that plane right there at the bottom corner. So symmetry requires that your origin be on a plane of symmetry. When I say requires, I mean I require it. It's not required by SolidWorks. So I'm going to go over here now. I'm going to start a new file. It's a part file, so I pick part. I get on and make sure that it's set for inches, pounds, and seconds. And if I look down here, it says custom, so I'll change it to inches, pounds, and seconds. I'm going to go to the sketch tool because I want to do a sketch. I told you to start on the top plane. So when I pick the sketch tool in the sketch tool box, I now pick the top plane by making it orange, and it looks like that. Because it's symmetrical, I'm not going to just start drawing lines. I'm going to start by drawing what's called a center line, which really should be called a construction line. And I'm going to put that center line right down through here so that it's attached to the origin. So in other words, I want the origin to be right here. So I've drawn a center line, and this is not a center line from a drawing point of view. It's really a construction line. So now what I'm going to do is draw what this part looks like above the line only. Then I'm going to mirror it below. So I'll go to the line command. I'll pick the origin, which means this is going to be sitting now on the origin. I'm going to go up. I'm not going to do that little cut because it doesn't go, well, because what I'm about to do is just make the bottom part of this. I'm doing that outline. I'm only going to go up to the bottom part. I'm just going to go up, come down at an angle, come down, say come over here, and that's where the slot's going to go. Now, generally speaking, I find that it's sometimes easier to just put a circle in instead of an arc. So that's what I'm going to do here. I'm going to say, let's draw a circle. And by the way, I'm not going to go over all these tools. You take a look at them and you can see rectangle, circle, polygon. You can figure out all the tools that are up here by looking for them on the command manager and then hovering over them. So I'm going to highlight here, but I'm not going to pick anything. I'm going to track down until it hits here, and I'm placing the center of the circle right on that line. And then I'm going to place a quadrant of the circle right there, and it automatically added the relations that I wanted because of how I put it in there. The circle is tangent to that line. The circle is coincident with that line. The center is coincident with the center line. And now I can mirror, and the mirror command is up here. I can mirror these items right here, not the circle because it's already got something below. And when I do, the feature tree disappears over here by going inside where I can open it up and look at it. All the entities I've selected are in that window. And this is a little different than AutoCAD as well. I do want to copy them, but I need to select a line to mirror about. So in sketches, mirror needs a line as its mirror line. I pick that center line and it goes down here. I know, can you see that yellow on that? All right. Okay, so the yellow shows you that's what it'll look like. You pick the green check to say yes. And now I realize, oh, I just missed something. Well, I can go back to the mirror command and say, let's mirror that by itself around here. Now it comes in here. Now the beauty is anything I do up here is going to be mirrored down there. Now, did I do a good job sketching? Not particularly. It's kind of a mess, in fact, but I'm going to take care of that by putting dimensions on. So far, so good. Now, and by the way, my video on YouTube specifically step by step goes through each one of the things I'm doing right now. Exactly the way I'm doing them? Probably not. I'm not that good. I don't have that good a memory. I do need to get rid of part of that circle. Anybody that's used another CAD program probably recognizes that the word trim is usually used to do that. And in fact, it's used in SolidWorks as well. If I go and pick trim, there are all these choices. I've only used one, power trim. Click, hold the mouse button and drag, click and drag, and now it's trimmed out. And the shading tells me I've got a closed shape, which I need if I'm going to extrude that. People with me on this so far? I'm going to do this a couple more times, so don't worry if you're wondering, am I going to remember this? I don't expect you to remember it. I'm now ready to put dimensions on here, smart dimensions. I'm going to say, what's the distance from here? And I can pick the center line. Because it's a center line, though, it allows me to give that distance or that distance. What I want is that distance. Right now, it thinks it's 5.1. No, the distance I want there is 2.3. It's going to distort this now by doing that, but it only does it momentarily because the first dimension I place is the one that establishes the proportional relationship between that line and everything else. Now, I'm going to say, let's give the overall length of it then. Again, smart dimension. I picked two parallel lines. It knows I want to give the length, 4.12. Okay, that looks a little better, but a little bit weird until I say, how far is it from here to this line right there? That's 1.9. Well, you notice how it's kind of coming together now. How about this and this? That right there is 0.3. And you notice everything I do on one side is reflected on the other. Now I could think I'm done but you probably recognize that I'm not. But those blue lines tell me those are underdefined lines, and it says underdefined down here. So now let's put the distance from here to here, which is the center line distance at 1.12. Now, gee, why is it still blue? Well, what did I leave out? Anybody notice? Something, right? Now, here's my tool. I want to figure out what's missing. I think it looks pretty good. I'm going to grab that and try to move it. Oh, wait a minute. Did I ever tell it the radius or the spacing? No. But by doing this now, it tells me, what did you leave out? What I left out was the width of that slot. Bring it over here, 0.78. Looks like that. That is a fully defined sketch. That is what you turn into me. So far, so good. Okay. Now, what am I going to do with that? Again, sketching by itself doesn't make anything. You have to use the sketch to create a feature. We're not going to do a revolve or a sweep or any of the other techniques you can use. We're going to do an extrude. How far are we going to extrude it? Well, how thick is it? 0.76. Could I go all the way up 1.5 and then cut stuff away? I could. I think that would be inefficient, so I'm not going to. But you could make a big block out of it and then machine the rest of it away. What I'm going to do instead is just make that 0.76. Now, is that the only way to do this? It is not. And as long as, excuse me, as long as you have no underdefined sketches, the geometry is correct, and your development of this is relatively efficient, I don't care if you want to bring it all the way up and cut it away. I just don't think that's the efficient way to do this. Now, what do we have to do next? Well, we have the end to put on. So I'm going to draw on this end of this. So I go back to the sketch toolbox, say I want to do some sketching. Why isn't it doing anything? I didn't pick the sketch tool. Now it winds around like this. Then I notice there's symmetry here as well. The minute I see symmetry, center line right through the origin. Doesn't have to stop on the origin, it can do that. If the center line's black, that means it's vertical and it's coincident with something. It doesn't mean the ends can't move. The ends are still blue, but it's a center line, which you don't make geometry from. So that does not underdefine it. Now what I'm going to do is say, I want to put a line here, 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 and I'm going to go over and stop right there where the center line is and bring it up through. Now I just made a mistake. You're not going to know what it is probably until I try to make an object out of it, but you're going to see in a minute. The distance from here to here, that's a dimension. By the way, I did something a little tricky to get the dimension tool. Its smart dimension is up here, but if you hold the right button down on your mouse and you start to move the mouse, you get this little wheel, and the wheel has by default 4 commands on it. Dimension's one of the commands, so you can pick it really quickly. This is why it's smart dimension. I'm going to pick that line and a non-parallel line, and it knows that I picked the center of that, or the midpoint of the line. That's not what I wanted. A non-parallel line, it knows I need to have an angle, so it'll give me the angle of 30 degrees. Distance from here to here, bring that over. Doesn't matter where you put this. This is not a drawing. 0.44. So now it still says underdefined. So I wonder why it's still underdefined. Well, I can't find anything that's underdefined about it. So I think I'm just going to go ahead. I'm just going to go do it. I'm just going to make it work oh, wait a minute. Oh, I see why it's underdefined. That never attached to this. So here's a case where with a line, you've got a blue dot. That blue dot means you can move it. When I hit this, now it's fully defined. Everybody with me on that? So those are the kinds of things you have to do when you're looking at this. Now I'm going to mirror those over. So I'm going to say, let's mirror those right to left, crossing, left to right window, mirror about that line right there and do that. Now, for a lot of people, they think that looks pretty good, but notice that there's no shading. Everybody see there's no shading? I don't have a closed shape. I'm going to, though, think I have a closed shape. I'm going to go and try to extrude it. And when I try to extrude it, it does that. And I realize I never drew a line across the bottom. You see that? That's what's known as a thin extrude. It says, oh, you're trying to extrude just a line that's not closed? Well, you must want a thin extrude, something where the line gets thick as it goes through, but it doesn't create a solid closed object. It creates a solid object given a thickness of well, the length is 0.76, a thickness of 0.1 inches. So when you do that, you're saying, all right, I got to have a closed shape. Well, that closed shape is going to be a line that sits on top of that edge. That edge is not a line. You can't use that edge to create geometry unless you either create a line by drawing it on top of it, or what you can do on a sketch is something called the convert entities. We say, take that edge and put a line on it. Now you notice it's all shaded in. Shaded in means it's a solid. When we come back over here to features now, I do an extruded base. It's going the wrong way, but at least it's filled. Over here is where all the controls are. So you have to come over here, and sometimes you're gonna have to look around and ask yourself, okay, what's over here? Selected contours? I don't know. I don't think that's it. Thin feature? Oh, he just showed us a thin feature. That's not what I want. Direction 2? Well, I only want one direction, but I want it to go the other way. You might have to just hover over a few things and find out what it does. That tool right there reverses direction, does that. This tool right here makes this all one thing. Do that, and now we've got most of what we need on this part. So far, so good? Yeah? All right. A couple of notches that need to go in the bottom. Once you have a part, you sketch on the part, not on the planes. So I'm going to say sketch on here. I'm going to use the corner rectangle command, put a little rectangle in here, put a dimension on it there. That dimension is 0.26. This dimension right here is going to be 0.4. Now you notice there's another one on the other side. And what a lot of people would do is draw the other one as well. I don't want you to do that. I want you to get in the habit of creating a feature that's symmetrical and then mirroring the feature. What we have mirrored so far is a sketch. So now if I go to features, extruded cut, I want that to cut through the part. Now, up to surface is the way I want you to always cut, where you say, start where I sketched and then go to that surface. Now it'll go all the way up to that surface and stop. What a lot of people will do, and you'll see this on YouTube all the time, is through all, which goes beyond the surface, or they'll just say, let's go blind, and then they'll just drag it so it goes beyond, and they're perfectly happy with that. The problem is, from a design point of view, if I change the location of that surface, I still want that slot to go through and hit it. So if I make the part bigger, I don't want the slot to stop. I want it to go all the way up to the surface. So from design intent point of view, the best thing you can do here is say up to surface, say stop it here. And then no matter what that surface does, changes angles, gets longer, gets shorter, it's still going to go up to surface. What do you think? So far, so good? Right now, we got a mirror function. Now, could I have put both of the sketches in that one sketch? Yes, I could. But I'll show you in a minute why I like it better doing it this way. What I'm going to do right now is under features, not sketches, but features. I'm going to find the mirror command, which is right here. A three-dimensional mirror, a mirror of a feature, requires a plane, not a line. That is what I have right here because of where I place the origin. I automatically have a plane of symmetry that goes right down through the middle, which means if I pick this, if I pick this as the feature to mirror, it goes over, does that. Now, the beauty of this is I only have to make changes to one sketch. That one corner, and it'll change them both. Now, that's if the part's supposed to be symmetrical. Now, how do I know if it's correct? By the way, I'm going to make two changes here that because it drives me nuts not to. I'm going to make this bigger. I'm going to go up here to that little gear, and I'm going to customize my mouse gestures because I like having not 4 mouse gestures, but 8 mouse gestures. So I have 8 places now that I can drag my mouse to do things. And that means I can do that and get the view I want, or that, or that, or this, or that. So all I'm doing now is right click and moving the mouse. You play around with it, you'll figure it out. Now, how do I know that it's correct? Well, first, I want to make sure there's no underdefined sketches. If you were careful while you were sketching, you probably don't have any underdefined sketches. If you were careful while you were sketching, you probably don't have any. But what I'm going to do is I'm going to open up all of these. And if any of those words that say sketch have a negative in front of it, I close it, point it out to you, give it back. It means it's an underdefined sketch, and your job is to find out why. Now, what else can we do? Well, I told you over here to assign plain carbon steel as the material, and that if you do that, the mass of this should be 1.9622 pounds. Well, there's a material option here. Right now, it's material not specified. If I right click and pick plain carbon steel, it changes a little bit, looks like that. And I can already tell that I have a mistake here, but you're going to find out why. When I do that, and then I go to evaluate and say, what is the mass? The mass properties of that, 1.97 pounds, which looks like close to it, but it's not exactly right. So if it's not exactly right, what am I missing? Something is wrong here. Now what I'd have to do is go back and look at all of my dimensions. So in this particular case, for this thing here, I'm going to look at that extrusion. I'm going to edit it. And I'm going to look at my model over here and say, wait a minute, I went to 0.76 on this. It's supposed to be 0.94. 0.94 is because that's that dimension right there. Now I can also double click on it and say, all right, what's the overall length? 4.12, 2.3, that looks right. 1.12, 0.78, that's right. 0.3, that's right. 1.9, that's right. That looks pretty good. Well, let's see what I did for the thickness when I did this. Right click, edit it. Did I make that 0.76? Yes, I did. All right. Is it plain carbon steel? It is. Did I go back far enough? Looks pretty good. Now I'm going to go to the mass again and check it one more time. When I check it one more time, it comes up 2.07 pounds. Something is wrong here. Something's out of whack. So I've got to look it over and decide what is it that's out of whack. Anybody see anything in here? Anything in particular?
Yeah, you're missing one dimension.
And what is that?
It is a dimension of 0.46 above the center line.
Yeah, that one I'm not missing because that's the result of this being 2.3, 7.78, and 0.3. So there's nothing else that could be. If we were going to put it in there, it'd be over dimension. But that's a good call. I didn't put that dimension in. But something is out of whack here, right? You can just tell that. So I can take a look at it from the front. And if I look at it from the front and say, all right, how does that look from the front? Well, it looks pretty good. If I look at it from the right, looks at it from the right, well, that looks pretty good as well. Maybe that doesn't look quite right. If I look at it from the top, space bar, looking at it from the top, it looks like that. I don't know. It doesn't, I don't see anything just obvious on that. So I'd have to go back in now to each of the sketches and check and see, did I do something incorrectly on that sketch? I did not do anything on this one. Let me show you the thing about what you set up here. If I put this dimension in right here, 0.46 is automatically the right dimension, but it also tells me it's overdefined. So, all right, well, I'm going to let you ponder that one, but you notice I'm not going to turn that in because I didn't get it to be right yet. But I want to show you something else. So I'm going to skip ahead and just say, all right, I got a problem. I better not turn that one in. So let me do this. I'm going to start the next one, but the next one I'm going to start is going to be started from the front view because I want to go through this again. And you can figure out what I did wrong when you watch the video. So we'll make a part. And trying to park that so it's, there we go. So I'm going to change it from custom. By the way, you can change this default. I'm not going to do it right now. I'm going to change it to inches. So I'm going to start this thing from the front. So I'm going to do a sketch. This sketch is going to be on the front plane. I'm going to sketch this like here. There's no symmetry here. So I'm just going to go do this. I'll make the little L shape on here. I'll come back. I'll come up. I'll come over. Now in the front view, the dimensions for that, 0.94. The dimension of the height of this is 1.5. The overall length of this part, 4.12. And then that part right there is the one that's 0.76. Looks like that. So there's my front view. I'm going to come over here, but I said I want that origin on the line on the plane of symmetry. So here, when I do a feature and do an extruded boss, what I'm going to do is instead of blind, I'm going to go mid-plane. And mid-plane means it's going to go in both directions, the same amount. So if I take a look at this, 2.3 is the total. I put in a 2.3 and it comes out, but it comes out symmetrically. So the origin is still in the right place. Now I'm going to do something from the back. I'm going to sketch on the back of this. I'm going to put in that little notch right there, that cut. I'm just going to say from here to here to here to here. The distance, the angle from that is 30 degrees. Tells me that the distance from here down to here is 0.44. So it looks like that. I'm going to cut through this part by going to Features, Extruded Cut. I'm going to go up to Surface, and that's a default because that's the last thing that I did. Go to that surface right there and do that. Now I'm going to do a notch in the bottom. And the notch in the bottom, I'm going to sketch with a rectangle. And I'm doing it on the same side as the other one. You can also turn off the fact that it keeps orienting itself every time you make a change. That distance right there going in is 0.26. And the distance right here is 0.4. Now I'm going to do another extruded cut. And that other extruded cut is also going to be up to surface. You've got all these choices here, but it's always going to take the last one. That's pretty new. I'm glad they did that. They changed that in the last release. Now I'm going to look at it from the top. And from the top, I've got a few things I've got to cut out. One of them is that little notch up there. So I'm going to sketch on here. I'm going to take a line. I'm going to do a sketch on that surface. I'm going to do a line. And that line is going to go, be careful you don't go to the midpoint of a line by accident, because I don't want to do that. I want to just click on the line, go to the corner, come down, make my little triangular wedge. Now I can put the dimensions on that. I can go to Smart Dimension, or I can move my mouse and get that. That line should be 1.9. This line right here should be 0.3. And that's everything I need for that. So now I'm going to make another extruded cut. And this extruded cut is going to go up to surface as well. And that surface is going to be this one. And the reason I put all of those things on one side is because I'm now going to mirror all of those things so that they're always the same around the front plane, which is why I did a mid-plane extrusion. And the features to mirror are going to be that cut, and that cut. And now what I need to do is put the slot in there. I go back to the front of the top view. I'm going to sketch on this surface right here. And I will put a center line that goes from here and comes out. That's going to be where my circle goes. So let's put that as a dimension of 1.12. Now I'm going to put a circle on that. The circle on that is going to have a diameter of 0.78. Now I can draw a line that comes from the top of this, goes over here, comes down till it lines up with that quadrant, comes over here. Now what I need to do is a trim. The trim's going to go here and here. That's the slot that I want to get out of there. I'm going to do an extruded cut, and that extruded cut is also going to go up to surface. There's the surface I want. And now let's see if I did a better job this time. One, are there any underdefined sketches? There are none. They're all fully defined. Two, what a material I want to add, plain carbon steel. And three, evaluate mass properties, 1.96. Well, that's closer. I had 1.9622. Let's go up here to options and say, you know what? I want to see 4 decimal places, not 2. 4 decimal places, okay, 1.9622. That one I'm going to turn in. Everybody with me on that? Now, there are two ways to solve the problem that I had in the first one. One is to carefully go through and find the error. The other is to throw it away and do it again. Doing it again at the beginning of this class is a little bit like taking piano lessons where you don't go and tell your piano teacher, I played that thing once. And she said, well, play it again. Well, I'm not very good. That's because you didn't practice. This is like a musical instrument. You practice, you practice, you practice. So from my point of view, if I'm giving, you're going to have to do this 3 times from 3 different points of view. I would do each one of them 3 times and just go through until you really understand what the tools are and how to use them. I'm not going to have time because it's 2 minutes away to show you what I would do from the right side view. But those two views cover the kinds of things I want you to keep in mind. So quick summary, no underdefined sketches, period. Symmetry, origin has to go on the plane of symmetry. If there's 2 planes of symmetry, on both of them. If there are 3 planes of symmetry, on all 3. You're going to do a cube, dead center is where that origin is going to be. You're going to do a sphere, it's going to be at the center of the sphere. And 2, excuse me, sorry about that. 2, make sure that you check that there are no underdefined sketches. Place the material on there, which is plain carbon steel, and then check the mass. And if your mass is wrong, you have a geometry error. Something's wrong with your geometry. Everybody with me on that one? And you could go back and watch the video and you'll see where I made that mistake. But you don't even have to do that. You can just go in and start doing it yourself. There's one other part to the assignment, and I'm not going to go over that. I want you to do it as a tutorial. Under question mark here, there are tutorials. It tells you that in the assignment description. And why did it go over there? And the one I want you to do is the introduction to SolidWorks. And it's just a somewhat different approach. There's some different shapes, and it just walks you step by step exactly what you want to do, but there's no video. It does it one thing at a time. And once you start it, if you don't know where a command exists, all you have to do is pick that little square, orange square, and it'll show you on the software, which for some reason got shifted to my other monitor. I don't know quite why it did that. But anyway, just go through and walk through this thing and do exactly what it says. That step-by-step tutorial might be a little bit confusing, but I did put a video together kind of covering a couple of things in it. That's what I want you to do for your first 2 assignments. Make sense, folks? You get so you can do that and understand what you're doing and do it multiple times, have all 3 of them be correct. You now have learned how to make precise models in SolidWorks on a part that is decidedly simple, but at the same time has enough complexity to it to make it worth figuring out at the beginning. We're going to go directly from this after we get done with this one to creating an assembly of something that has multiple components and has different ways of creating the geometry. And you're going to put them together. We're going to do drawings. We're going to do the whole package on the first project. And then we'll do another project like that. And what we're leading up to is at the end of this class, not only will you take the certification exam, you'll also have your own project to submit, and that's going to be worth 15% of your total grade. And your own project simply means something you care about enough to want to design it. Has to have multiple parts, has to have assembly, has to have drawings, but I'm not going to tell you what it is. I want you to use this tool to start off designing something from scratch. And all I care about is that you really want to do it. So, you know, you're a nut about antique clocks and you want to make the works of an antique clock, which I had somebody do once. Go with God, because it's going to take a lot of time. But boy, did he do a hell of a job. You want to do whatever, you know, you got a truck. I mean, I've had people make lifts for their pickup trucks and, you know, some units in the back that go up with their snowmobiles on them. I've had people do kitchen stuff. I've had people go, I had somebody last class, Aiden remembered, someone said, does it have to be useful and something you could actually make? I said, I had one of my best students ever said, I'm going to make a steampunk lamp. And I said, how is a lamp going to run on steam? She goes, no, it's a steampunk lamp. I go, well, why a punk? I mean, and how does a lamp run on steam? I don't get this. She said, oh, here's a link. And it turns out this is a whole like design, like decor thing. You know, people make like lamps out of pieces of pipe and stuff like that and welded stuff. I had no idea there was something called steampunk. Did I let her do it? Absolutely. As long as she had no underdefined sketches, she had an assembly and she created drawings of all the parts. So those are the things I'm going to require you. So start thinking right now about that, because I really want you using the software. And if you do that, The people who use the software for something they really want are the people who get good at this software. Questions at home? Jeff, anything? Matt? I got to hit thumbs up. Aiden, you're good? Okay, Randall, huh? We're good? All right, folks, I'm going to go home and see my wife and probably cook her dinner. Okay. I love teaching this class. I hope you figured that out. And I really, really looking forward to seeing what you guys do on your final project. So I've got my open sessions. You see where they are. I'll be on Zoom for all of them. I'll be in person in my office for several of them. I'll be up in Brunswick on Friday. If you have any questions and get on one of those open sessions, you can send me an email if something comes up that, just isn't working right and you think it's something wrong with it. I'll try to get back to the emails as quickly as I can, but I will be on those Zoom calls during those times. And unless I'm working with somebody else, I'll be available to answer whatever questions you have. Okay? Good? All right. I'm going to stop sharing. I'm going to quit this Zoom and say good night, and we'll see you next week.